Welcome to the meeting, everyone. If you could please sign in, helps keep track of attendance and everything for elections and eligibility for running for office. Stay informed. You can join our mailing lists. We send out emails once a week for upcoming meetings and workshops. You can visit our shop and buy all kinds of fun merch, including our t-shirts. You can join our Discord there, where we post most of our information and you can communicate with other members. And you can follow us on Twitter, where we send out various announcements. Today's topics, we got current events running with Daniel, introduction to web security running with Jeffrey, and that's it. Operations, come help run the club. We run Tuesdays, 8 o'clock on Zoom. Anyone can join. Come help plan whatever you want. Make the club more like what you want it. Here's some announcements. We got t-shirts, elections, nominations, CTS upcoming, US Cyber Challenge, and National Cyber League. Here's some new merch. You got 3 shirts for this year. You can go into the shop if you're a dues paying member, and we'll receive a code to get a discount, $10 off your shirt choice or shirt design choice. Elections nominations are going to be accepted from March 19th to April 6th. Elections are going to be held on April 9th. For our requirements, you must be an active student member of the club, mean that you followed the steps on the join page, and you've attended 50% of the meetings for this semester. You must have also been an active student member in the fall. If you're not sure about those requirements, feel free to email ops@hackxss.org, and we will let you know what requirements you meet. UCF requirements: if you're undergraduate, you have to take at least 6 credit hours, maintain 2.5 GPA. Graduate students must take at least 5 credit hours, maintain a 3.0 GPA. Read all about the requirements on the Constitution page. CTS needs some practice. Head over to our ctf.hackxss.org and check out ctftime.org to learn about more competitions. Registration is now open for US Cyber Challenge, the 12th annual. Registration costs $0. You should join in. The competition ends on March 14th. National Cyber League's open. Registration costs $35. Totally worth it. Great for learning and everything. It's individual games from the 26th of March to the 28th of March, and team games from April 9th to April 11th. All right, on to current events with Daniel.
All right, thanks, Addison. Go ahead and click on the next slide. Cool. So Hafnium strikes. Atomic number 72 coming to an Exchange server near you. This one's kind of interesting. So 4 zero-day vulns were exploited in a kill chain to effectively leverage an ability for an attacker to hit a on-premise Microsoft Exchange server and to exfil the entire account's data targeted. So that is emails, calendars, contacts, tasks, attachments. So as far as I'm aware, while researching this, that meant that basically if one server was targeted, even one server, the rest of the server could likewise be targeted. It does appear that most of these are surgical strikes in nature. They're not just like getting all the data they possibly can. They're stealing very specific stuff. To dig into the details a little bit, the kill chain follows. The first CVE, the 26857, was used to run code under the system account. Then 2 different CVEs were used to write a file to any part of the server, which leveraged a server-side request forgery in Exchange that was used to steal the mailbox content. The group responsible, or that they're attributing responsibility to, are codenamed Hafnium. They're suspected to be operating out of China, but the details are a little sparse right now, and pinning it down just yet is kind of difficult. They've been responsible for similar attacks on internet-facing servers, but this is the first time that they've done a hit like this. The most vulnerable were Microsoft's Exchange servers in on-premise configurations, and the attack was reported as early as the 3rd of March, and there are updates occurring daily. Some of the updates apparently don't even fix the vulnerabilities that have been exposed. So this is definitely going to be an ongoing thing. And if you happen to have a Microsoft Exchange server, you should be following this very closely. Next slide, please. So for when you actually need MFA, you might want to consider getting a Nitro Key. The newest version, Nitro Key 3, is been opened up for pre-orders and is looking pretty awesome. The entire suite of applications built into this one YubiKey-like device is written in Rust using the Trust Secure framework. It's implemented on a very security-focused microprocessor, the LPC 55S6X, which is ARM-based, and it is certified using the common criteria EAL6+, all the way up to the OS level. Not only that, but all of the code used for this project is open source. So it's pretty fantastic. You should definitely check this out if you are an individual in a business looking for a new MFA solution, or if you're just looking for your own personal MFA solution. The number of features listed on this thing would have filled this entire slide, so I can't go into it too in depth, but it's really awesome, and I highly recommend reading up more on it. Next slide, please. So let's talk about Gab. According to the CTO, Andrew Torba, they were targeted by trans demon hackers. The social media platform was breached, allowing 2.999 gigabytes to be exfiltrated off the site. Now, a lot of this was in text and like secure text and email addresses and hashed passwords. The link that I read up on was posted by Troy Hunt, going back and forth over several days, who is the owner of Have I Been Pwned. If you aren't familiar with Have I Been Pwned, they do a lot of password hash cracking and verifications of database leakage, basically allowing you to go to the website, type in your information, and see if you've been hit on any of their leaks. As far as I'm aware, this particular leak makes like over 500 or something leaks posted to their website. It's let's see here, I've got the information. The 515th data breach added to Have I Been Pwned. So that's pretty neat. The group responsible is unidentified at current, but the CTO, Andrew Torba, is saying some pretty vile things online about the whole thing. So just be aware of that. The breach occurred apparently because the CTO did not implement proper sanitization techniques, allowing for a Sql injection to be leveraged against the website. Don't know exactly the depth to which this vulnerability exists and or if other vulnerabilities were used. They've been pretty evasive in talking about the breach altogether and have been very hateful in directing exactly what it is that's going on. So this is just another hit on Gab, and I expect that we're going to get a lot more of this in the future. And that's it. Next slide.
Okay, so let me just share my screen before we begin. Do you see my screen, guys?
You're good.
Okay, thank you. So before we continue, I know we had some hiccups with the sign-in form. Don't forget to sign in at hackucf.org/sign-in. If you also haven't signed the ethics form, it might be a good idea to consider doing that by the end of this presentation. So, did my screen stop sharing? That's unfortunate. Yeah, there we go. So before we continue, who am I? So hi, I'm Jeffrey. I am a software developer who mains Linux servers and likes to abuse JavaScript. I am the secretary of HackUCF and in charge of compliance, as well as a developer at Zenith Dev Team, which is a small development team made up a bunch of young developers in the jailbreak scene. I'm also in charge of documentation for Cilio Team, which is a package manager for jailbroken iOS devices. So I am very like a big proponent of making things to learn, and hopefully this presentation will kind of rub some of that off of on you. As for what I'm going for, I am a sophomore here at UCF, going for my computer science major. So what should be the takeaway from this talk? So we're going to be talking about how to perform basic cross-site scripting attacks, as well as other basic web attacks such as injection, which Daniel alluded to earlier. We'll also learn practices to better secure these applications by learning how they happen in the first place. Some questions I want to answer: how does a web page load? How does TLS work on a surface level? What's the document object model? How does cross-site scripting work? And what is script injection? So some of the things we'll be covering, we'll have a section on how a web page loads, the document object model, script injection, and then a little addendum on trust in development and security in general. So first, let's load a web page. Pretty simple start. So when you go to a website, you usually get thrown on to just the website. You see the page already rendered. But what's actually happening under the scene? If we take a look at the network traffic being sent here, we can actually see what's going on here. If you don't have a network traffic viewer, actually your browser has one built in, as well as tools like Burp Suite and Fiddler being excellent for this kinds of stuff. So let's dissect this screen that we have in front of us. So what are each of these elements? So first, we have pretty clearly the domain or URL that we are connecting to. We also have the request method. So is it a GET request where you're, as the name implies, getting information? Is it a POST request, meaning that there's additional stuff in the request's body that you want to send to the server? Or maybe it's something else. There's others like delete, push, and this one connect, which we'll get into in a bit. And then we have the response code from the server. So this is just what happened as a result. If it's a 200 class error, it was a success. That means the page loaded successfully without any issues. 300 class errors, maybe something happened that you had to tweak, like a redirect. 400 class errors are a user error where you tried to access, let's just say, something you don't have permission to view. And a 500 class error is the server crashed, most likely. So things that are not shown here, we have headers in web requests, which is metadata about the request, which includes stuff like what browser you're using. Maybe if you don't want to be tracked, that information will be there too, as well as some flags about how your browser should handle like remote resources, which we'll get to in a bit. And then also you have cookies and the request and responses contents, among other things. But you don't need a web browser to send these requests. Of course, a web browser is the easiest way to do it, but tools like wget, curl, netcat, etc. can allow you to facilitate these network traffic requests. But wait, we saw the full URL on an HTTPS connection, aka that connect method. So what is this? And to answer that, we have to talk about TLS. So TLS, in summary, is how your internet traffic remains secure. Most notably, we have asymmetric and symmetric cryptography whose differences will complement each other and will allow you to perform a handshake, which was designated with that connect method in the web traffic. So to massively simplify what's going on with TLS, you have 3 steps. 1, the client and the server exchange hellos. You have the client hello and then the server hello. And during this, the server will also send over a certificate to identify itself. Also, after this happens, then security stuff happens. I'm not going to go too much in depth because it varies based on different versions of TLS. For instance, in the old version that's on screen, TLS SSL, you would have a client key in cipher exchange before you got into step 3. But nowadays, it's a bit more streamlined and actually faster and more secure. And then after that, the client and the server have agreed that they trust each other and can securely communicate without eavesdropping. But there's a slight issue. What if the server itself that is trying to man in the middle of someone has a certificate and say, hey, I have HTTPS. I'm going to do this TLS handshake process. Well, it doesn't exactly work like that because there's certificates. And while TLS at its core just wants to make sure what happens isn't intercepted, the step that adds the certificate makes sure that it's a trusted connection and not just someone trying to hack you. So certificates tell us whether a site is legitimate or untampered with. And how do we trust these certificates? We trust the issuer of that certificate. And that issuer was trusted by another issuer, which was trusted by another issuer, which go down the line is eventually trusted by this apex point, which we call the trust store. So the trust store is most likely managed by your operating system or your browser, and pretty much is the one who lists all the root certificates that that company or entity trusts. So while you might trust Apple to not help a hacker man in the middle you, or you might trust Google to not do that, you're most likely not going to trust a nation state with the ability to designate what is trustworthy or not, because unfortunately you just won't trust you just don't trust just anyone, if you get what I mean. So we're going to actually give a live demo of both the web request process and TLS and certificates and whatnot right now. So if I close this, okay, let me pull up chat as well. Yes, don't trust anyone, not even yourself, which is funny because, well, I trust myself here. So we're going to right now go to a website that I run. So if we load up this is just a pie hole, nothing really special to see here, but this is a site that is protected with HTTPS. And if we want to see this for sure, we can click this lock and note how it says that Mozilla doesn't recognize the certificate issuer, because unlike what Alex said, I did end up trusting myself in this case. I issued the certificate. So if I go ahead and view certificate, then we can see that trust chain. We have the Sugar root CA, which then issues and trusts this intermediate CA, which then eventually will trust this specific website ad.sugar. So if we want to see that my OS is trusting the root CA, we can actually look in Microsoft Management Console, which is where the trust store on Windows is stored. So if we add the certificate snap in and click OK, then we can start browsing my computer certificates. In this Trusted Root Certificate Authorities folder, we can see the Apex Trust Store for Windows. A lot of these I didn't add myself. Windows trusts that VeriSign isn't going to do anything shady, and they trust that they're probably not going to do anything shady. But at the same time, if any of these root certificates are compromised, they have to be revoked. So then you, instead of trusting it, you're doing the opposite. You're untrusting it. And then here we have this oddball Sugar root CA, which is the one that is protected by my website. So I can just view some of the details about the certificate there.
Hey, Jeffrey, we can't see the MMC panel.
Oh, you can't? Let me fix that. Okay, share whole screen. Okay, can you see this?
We see, there we go.
Yeah, so as I was saying, we have these 3 certificates, which is powering this HTTPS enabled website. And if we go into MMC, we can see we have stuff like the VeriSign public primary certificate here, issued by VeriSign. We have like the CyberTrust root here, DigiCert, and these are issued by Microsoft. But you can actually add your own if you trust another entity, which is specifically useful if you're in a corporate network. So here is the one I issued, and we see that it's at the top of the certification path, and that it was issued by itself and verified by itself. So we can also see some intermediate certificate authorities, but you don't have to trust the intermediate in order to trust anything that was issued by the intermediate, since you already trust the top of that food chain in a way. And some of these include like what I have here for, yeah, it would be keychain. Yeah, Fiddler Root. We have also Portswigger CA, which, completely legitimate. Unfortunately, I will not be going over Burp Suite today, but a lot of these intermediate certificate authorities are more of my man-in-the-middle attack tools. So we can close MMC and now go to this site. Now, I'm logged in. If I log out, like right now, I can see like top permitted domains and stuff, but if I sign out, all that fun metadata just goes bye-bye. So I just get this surface level info. But if I log back in, then I can see it. This, of course, also applies in incognito mode. If I am not logged in, of course, I can't view stuff exclusive to logged in users. So I'm going to open the web request tab in Firefox, and we can see that all these XHR requests are making connections to the API. And we're going to try to see if we can find this stuff for permitted domain, or nope, that's not it. Let's try this one. And there we go. We got some data about the top sources blocked, top sources of all the network in general. And this is just a part of the API. So this, if I access it without being logged in, a lot of the data is missing. So comparing to the left, we have these top sources and top sources blocked. But since I'm not logged into the right, since I'm in incognito, they just won't show up. And we can actually do this and replicate this web request in curl, which is a tool that allows you to send web requests with the console. So do you guys see my terminal window?
Yes, you could.
Awesome. So I'm going to plop in this web request and I'm going to send it. This is using Windows Subsystem for Linux, by the way. Oh, so we have this SSL certificate problem. What this is saying is that because I issued the certificate itself, it's not like trusted by, say, Let's Encrypt, then we like don't know it's legit. And my WSL instance hasn't added this to the trust store. So we're just going to ignore this. And there we go. If we zoom out, we can see that we have all the data that we'd expect for being logged in, even though we're not quote unquote logged in with the GUI. And the reason we're logged in is because of these cookies. So one of them is this PHP sessid, as well as persistent login, which are two of the cookies that contribute to my logged in session over in Firefox. Now, if I change this, even with just a character, let's just change this 9 to an 8 and this 2 to a 3. Very minor change. While it's going to do the web request, some of the data, like if you saw earlier, we had Jeffrey's iPhone. We don't see that because we're no longer logged in to the website. So now I'm going to just close that and we can see that here we have the cookies. Normally these cookies would be super secret and you wouldn't want to share them to anyone, but this isn't real TLD. I'm resetting the login anyways afterwards, so we don't have to worry about that too much. Unless you break into my house. MMC, if you want to access it, is going into run, and I just ran MMC inside of run. And then just approve it. And if you're following along, you can also go to File, Add Snap-in, and you can do this with Control M, and then Certificates, Add, Computer Account, Local Computer, and then you can view all the certificates and some other fun stuff on your computer, like for instance, you have like the certificates used by remote desktop here. So this is my RDP certificate. Unfortunately, it's not trusted by anyone, not even me. So how do I get dark mode on MMC? Abuse of Windows. So, okay, you see the PowerPoint now?
Yes.
Yeah, I did dark mode through theme on Windows, not anything in MMC. So let's go back to that example website that we had up earlier. So we can, of course, go into inspect element to view the source code of this website. This is HTML. It is the markup language that makes up most of the modern internet and past internet alike. A lot of people will sit here and they might see code or they might see a markup language, but as a computer scientist, I see a tree. So behind the scenes, the browser is taking this HTML or XML document and making connections by having its hierarchy being modeled with this tree that is does have a name. It is called the document object model. And the reason the browser does that is because it's easier for the JavaScript and the browser to render. So the document object model, or the DOM, is a tree-like data structure that allows you to access the elements of a web page. It's a data structure that interprets XML documents, along other things like HTML, which is based on XML. And this is how client-side JavaScripts actually interact with the page and change stuff after the web request has already sent the original HTML file to your browser. Each node contains a lot of information. It controls stuff like the parent, the children of it, what HTML markup is inside and outside of the node, JavaScript functions even, and a lot more. Essentially, each node in the DOM is an element on screen, and there is a lot of stuff in each node, enough to abuse. So that begs the question, can we abuse the DOM for our benefit? Why, yes, we can. So it's time for cross-site scripting with some flashy text. So before we continue, just want to note now that don't hack random people. It's not just not cool, it's also illegal, and breaking the law is not something Hack UCF will want you to do. So if you haven't signed the ethics form already, please go to the link on screen and sign it quickly. And if you refuse to sign it or don't agree what's on it, either leave the Control W, leave Zoom or YouTube or wherever you're viewing this on. But with that disclaimer out of the way, let's talk about what XSS is. So XSS is an injection vulnerability that lets us run arbitrary JavaScript on a website. It can be prevented by proper sanitation keyword. No, you cannot, Andrew. It can be prevented by proper sanitation and is usually caused by a lack of any or proper sanitation. There are two different ways you can model XSS attacks according to OWASP. So one of them is the client-server distinction, where client XSS is where the DOM is updated after the fact to include the bad code, while server side is when the payload isn't sanitized by the backend before it even gets to your browser. So that payload with the malicious code is sent from the server instead of being changed on the client. And then you also have stored and reflected XSS. Stored XSS is persistent. It is stored somewhere in a database on that website and is probably going to stay around for a bit. While reflected, as the name implies, means that you have user input that you give it and is being outputted or reflected in an unsafe manner. You can see this in like search queries that might like get formatting a little funky. I'll show you an example in a moment. And we'll be looking at both an example of server and client XSS. So on the top, we have a site that prevents XSS. This is actually the site I got the funny glowing cross-site scripting text. And then the bottom is a bootleg site that doesn't. Now, worth noting that this search, when you click enter, it loads a whole new page when you're doing it. It is sending an HTML document custom generated for that search query to your web browser. But you might notice that on the top, you have what you'd expect. You have exactly what you put in the search bar on screen. But on the bottom, the formatting's off. Like, it's almost like someone put a paragraph text in the middle of the search query and just rendered it like there was nothing wrong. This means that it's likely vulnerable to what we call a reflected server-side cross-site scripting attack. This label, while it might seem like a mouthful, is just a tool that allows us to describe what's going on. We know from the name that it's reflected, meaning that it's caused by user input, and that it is server-side, meaning that the payload was pretty much not sanitized on the server and is essentially the server's fault. If hypothetically we added a feature to this bootleg word art site that included like a list of people's recently searched queries and that also didn't sanitize stuff, then that would become a stored XSS because now that payload is stored in some database somewhere. So we're going to have a live demo of XSS in action. So some background. So I, as the secretary of Hack UCF, made a little tool to make those little social images that we put on social media and our Discord. And the thing about these, though, is that somebody rushed to make them. And because of that, they may or may not have a few vulnerabilities we can exploit. So we're going to actually be exploiting this tool that I made to help automate some things here at Hack UCF. And we're going to hack it. So to do that, I'm going to open a new tab. So I believe it's xss.sugar. And there we go. So we can see this is the tool that I use to make the advertisements for Hack UCF. So I can put in some text, and then it allows us to put just HTML code in it, which we can see from this tip here. And then we can export it as an image. These images are just normal images, nothing suspicious about them. But I noticed that because that, hey, it says we can just put in valid HTML, maybe like there's an XSS vulnerability. And if we actually look at the code, we can see this whole thing is just made up of HTML elements that are styled. We have this div, which is just a box with a background color. We have some titles, some paragraphs, and some other stuff like this image. So maybe if we actually look here, look, we got our bold text enclosed by the B tag that we put into this text box. So can we exploit this? So yes, we can. So I'm gonna, before I actually get to that, I'm gonna just plop in a script tag. So in JavaScript, a script tag allows you to run JavaScript on the page inline. So if you don't want to link to an external JavaScript file, you can just put it in the page. And there's a few other ways to run JavaScript inline. So normally you would expect that this, if it was just thrown in untrusted into the, that, hey, maybe some bad code will run. But our browsers are actually pretty smart nowadays. It detected that this was probably not right and won't actually like interpret and run this code. So we can see that it's an element on the page, it's in the DOM, but it is not being run. But that just means that we need to give it a bit of a nudge. So let's try a different payload. So you have the image tag in HTML, and I'm just going to give it an image. I think we'll try a different site. We'll do logo for my site. There we go. We got an image in the page and it kind of doesn't fit, but that's all right. So we can use a attribute of the image tag, which is on error, to actually run code when the image unsuccessfully loads. So onload equals alert XSS. And when the image loads, then make an alert. But why go through the effort of actually loading a web request to load the image when we can just use on error instead, which does the exact same thing? There, we got code running. And here we have a broken image that is causing the payload. So on the second box, I actually decided to slip in a patch. So we're going to try to defeat that patch. And to see the patch, we can see if we paste the same payload that worked in the above text box, it no longer works on the below one. So what's going on here? So I'm going to just take a look at the page and see if something looks off. Yes. To me, it looks like they were sanitizing the quotes. So we're going to see if we can find where that sanitizing is being done. So if we navigate to body, we're going to see if we can find the script tag. And here we do. So if I go on another tab and open the JavaScript, we have the code for the site. Now, JavaScript, usually it would be obfuscated by your CDN like Cloudflare, but in this case, that doesn't happen. So we can just easily view this. And even if it was obfuscated, it's easy to defeat. So we can see that if we actually look on this text box, okay, we got section 2 body. Let's see if we have an event that's triggering the updates. And here we do. We have on key, everything in element will have an on key up function run the update function up here. And this update function just edits the page and it uses inner HTML. The thing about inner HTML though is it's unsafe if you aren't careful, because anything you put assign it to, it will allow HTML to be put into the page and then interpreted, added to the DOM, and then if there's something bad, it might run. So we're just going to take a look at the differences between the non-sanitized and the sanitized versions down here. On the top two text boxes, we can see it is just replacing the value with this like encoded with the less than and greater than being their code point counterparts, ampersand LT and ampersand GT. If we go a bit down, we can see also the close tag is getting that treatment. And for this final one, it is passing it to a sanitize function. And then we can look at the sanitize function, which takes in a string and returns a string, replace all the quotes with an encoded version of a quote, same with apostrophe, and same with script. And then it also has a case for new lines. So to me, since it's only escaping the apostrophe and quotation mark, maybe we can abuse that. So if we go ahead and just see what we can do. I know to try a bit more of a novel example, HTML5 has this details elements. If I can type. So it's a pretty novel element. You click it, you get the details, and you can unclick it. But we can actually run code when this is toggled. So on toggle, and we can now have a function. But we can't use quotation marks because it strips them away. So you have to kind of know how the page kind of renders here. So I know that if you have a continuous string without any spaces for the most part, you don't need those quotation marks. So we can do something like X document, because we can't use quotes. And then if we toggle it, code runs. But it's not ideal because we have to actually do a thing before the code runs. And also, we can't really control the payload. So I think the next step is going to be showing that in JavaScript, unlike HTML, there are three kinds of quotes, at least. You have the apostrophe, you have the quotation mark, and then you have a template string, which is designated by a backtick. And these are usually not sanitized by some older websites because it's a newer JavaScript feature. So we can do something like this, and now we can control the text. So finally, I want to make this automatic. I don't want users to have to actually open a thing for our payload to run. So we're just going to have it open by default. So this will allow us to have the code run by default because it starts by default closed, and then the open tag toggles it open, thus code running. So that's just a brief demo of how a basic cross-site scripting attack can look. The thing about XSS though is there's almost an infinite amount of ways you can pull this off. It's an attack that requires creativity and an understanding on how browsers and the web works in order to exploit. So with that out of the way, we're going to take a look at some other examples of injection. So here we have two other potentially familiar examples of injection attacks. So one is a Sql injection. This is a super common one. In fact, it's how, as Daniel said earlier, Gab ended up getting their data hacked. Yes, little Bobby tables. Another thing, XKCD, great comic, and definitely would take a look at Exploits of the Mom if you haven't run into it already. It's pretty much the Sql injection comic. So what this is doing is we have a string, and we in this box can put anything. We're just putting whatever the user provides us on a website and just dropping it into this command. That is nerve-wracking because it is not doing anything to make that user data trustworthy. It's just plopping it in. And this is a potential problem because what if some mom, say the mom of Robert little Bobby drop tables, decided to put in their child's name, which included a SQL command. So it closes this SQL command here and then has another one right afterwards that is considered valid. And when the program tries to run this whole line, it runs insert into students, name values Robert, and then it runs drop table students and then something else. And that shows that, don't trust user input. And then this is not the only example of injection attacks in the web. You have another example of just script execution in general. This is especially handy for CTFs. If you're at last week's meeting where Michael was able to get into the Kronos server, he used this kind of script execution on top of a little SQL injection in order to do that. So in this case, our template box where we're just plopping in user data is looking for normally like an IP, so 8.8.8.8, but instead we're telling it end the ping command, use wget to pull some malware off of my server, then chmod it to be executable, and then run it. The recordings are on either YouTube or on Canvas if you're a dues paying member. So here, this entire line, ping w, and then this 3-4 commands, this is all run in that same line because we're just taking user input, dropping it into something that is being run with string concatenation, and just doing it unsafely. And this is bad and also common in CTFs. So might be worth having in your toolbox. So of course, we want to be able to secure against these attacks, but how? Usually it comes down to sanitizing or cleaning up anything unexpected in the user input. Usually it's a good idea to have a library do this for you because there's a lot of edge cases, especially as the web is an evolving beast where new and new techniques come out. Seems like almost like every month as JavaScript updates. And you don't want to, as the developer, have to deal with all those edge cases. And of course, as mentioned earlier, XSS isn't just one vulnerability, it's a class of them. And because of that, there's a lot of ways you can do it. So you can't just strip out just this one naughty example of code execution and just call it a day. Everything is fixed. You have to do it properly. But in a case where you might not be able to do it with a library, you can also URL encode or otherwise escape the characters. If you saw earlier when we were looking at the JavaScript code of that one site, it took that percent QUOT um, freaking semicolon, and then it took that and that displayed in the browser the quotation mark. It's like also in the URL where space would be represented by %20. And this would be a great way to stop most cross-site scripting attacks because then some of the bad characters that would allow you to break out of the DOM, like the greater than or less than sign, they won't be interpreted by the browser's parser. And another thing is just be careful on how you concatenate. exec and similar commands are quite dangerous because you can just put any user input into an executable string, and if it's concatenated, then that whatever the user wants will run on the server. And there are ways around this. You can sanitize it, but it's also worth considering that there might be a command that might better do the job. For instance, Python has the subplot process library that allows that a command to be passed as an array of arguments, not as a single string that's blindly executed. This is nice because then it's not being put into, for instance, a bash shell. It's just being passed to the program as arguments. So this can prevent you from, let's just say, the aforementioned, we ran a ping, now let's download malware example. And while sanitation is the way to prevent injection attacks, we have to consider the human. Unfortunately, we are human, errors are bound to happen, and we should prepare instead of just fixing it when we get around to it or find out that a bug exists. So that begs the question, can we just block any untrusted JavaScript from running in the first place, especially if we're trying to prevent an XSS attack? Well, we can. By using the content security policy header in the HTTP request, we can block any untrusted scripts from running. We can block inline script tags, lest we pass a hash of a certain inline tag we want it to run. We can have an allow list or a whitelist where remote access assets can be loaded from. So if you try to download a JavaScript file from badwebsite.com, it will be blocked because it's not whitelisted in the page. And then you could also have your browser be a little snitch and add a header that will, if this policy was attempted to be broken, send a report post request to your company or wherever, put in a SOC, have someone else deal with it, and then take action accordingly. You can also do this with a meta tag if you aren't able to edit the headers of a request, which would especially be useful if you're using a static hosting service like GitHub Pages. And yes, while this has been a relatively brief presentation, I do want to end on one more addendum. What do you trust? Who do you trust? A lot of security comes down to these questions because everyone's threat model differs. And there is one common element in all of these different threat models. You're probably not just going to trust anyone. You're going to be somewhat picky. So a reason I bring this up is because as a developer, you have to make these decisions on who to trust and how to handle stuff you don't. Sanitation is essentially an algorithm to take untrusted user data and convert it to either trustworthy data or trash it altogether. But not all web security, counterintuitively, is about preventing code from running on server or client, because especially with websites with established reputations like a news source, digital assistants, search engines, you want to make sure what you're putting on screen is trustworthy. So what if you decided to include someone else's scripts or images? What if these other parties decided to pull a little quick one and just change them, made JavaScript in a library that instead of doing its intended task, ran vulnerable or even worse, intentionally malicious code? Or what if an image that you put on your blog was replaced by this news source is bad, don't use them, or something like that? Or even what if like a fact aggregator takes in bad facts, like someone edited Wikipedia to advertise a Whopper sandwich? If these external scripts go rogue, it might not seem like someone is hacking you directly, but it will still cause very real damage, and we have to prevent this as well. Of course, there are things we can do to reduce the amount of third parties we can trust. So if you're using a remote JavaScript library, you could actually provide an integrity argument in the script tag to prevent load if a remote resource was tampered with. CDNs are great. Yes, zero trust. CDNs are great and offload some of the load that would be on your servers to someone else's, like Cloudflare's. But if you want to make sure that it doesn't get changed in a future update, then you could add a hash sum to the script tag. So if this remote resource doesn't match the hash, then it just doesn't load in the first place. Second, make sure you fully trust any tracking scripts or advertisement libraries you add in a website. I see a lot that someone would have a smaller ad framework, and then their web app is just filled with shady pop-ups to download some VPN that's just siphoning your data off who knows where. And as for instance, a news site, you want to make sure that the ads advertise what you want it, and that those ad frameworks aren't tracking users in unexpected ways or potentially themselves running malicious code. You don't want it to redirect someone to update your Adobe Flash Player that's been discontinued a few months ago, because that looks bad on you as the site maintainer. And finally, if you have a concern with someone's hot swapping out an image that you load from some third-party site you copied from Google Images, then just host it yourself if you can own the copyright. If you can't, find another image. But if you're able to, host the image assets yourself, because then you know it's not going to change because it's living on your servers and not someone else's. And of course, there's other examples. If you're aggregating data from any API's website, do you trust that API? Do you trust the person or entity who's providing the data for that API? Do you have measures in place, or do they have measures in place to prevent if their data set is vandalized? And also, don't accept facts from just any website, which for a human seems like common sense, but robots unfortunately can't reason and critically think as humans do. So it might be worth having an allow list to say, here is a list of sites we trust, only have fact snippets from these sites. And yes, if you do misplace trust, it's a matter of time before it's going to be abused, and I speak from experience here. Ad networks will be hijacked to push malicious content if that's in their best interest. People will edit Wikipedia articles to advertise the Whopper because smart speakers also use Wikipedia. And yes, someone will abuse their position being listed in an obscure search engine to make a Discord bot run Minesweeper. So of course, this is just a tip of the iceberg when it comes to web security. There's a lot I didn't cover, such as cross request forgery and cookies and stuff like that. And here are some resources that I recommend if you want to learn more. As for tutorials, I linked to one is a bit more in depth on TLS, while the other one is a cross-site scripting tutorial from Portswigger, which is the company who makes Burp Suite. And these tutorials are great, but if you want to be a bit more open-ended, both the OWASP and Mozilla Web Docs wikis are essentially the Bibles of web security and web development, respectively. You can probably end up in an hours-long rabbit hole on both of these sites to learn about both common and obscure APIs, attacks, and more for web development. And also tools. I would recommend either Fiddler Anywhere, Burp Suite, Charles Proxy as your man-in-the-middle proxy, and there are tools like Postman, Insomnia, and more that allow you to graphically compose and send web requests. But you don't need those tools for some of the more basic stuff. You could do a surprising lot with just a good old terminal, text editor, and web browser. Web browsers have a lot of debugging tools built in for web developers. And as a security researcher or a developer who wants to make their site more secure, you can use this and test it and see if can you exploit your site. And you can use the terminal to use tools like curl. I believe there's also the command line tool MITM proxy and a few others that you can use to just kind of make and mess with web requests, as well as other things. And then, of course, a text editor. Text editors are great. I think that speaks for itself. And finally, like practice. I've been doing web security and just web and mostly web in general for a long time. And it was because of my experience in web development that I was able to learn about web security. Because as a web developer, I want to be able to develop my apps with a security first, not a security second or security tacked on top of it mindset. Because if you write code to be secure, you're more likely to be mindful of bugs that might lead it to be unsecure. Some of these are simple decisions, like using a framework to sanitize user input, or even just using the inner text property to edit text on screen instead of using inner HTML. Or using, instead of scanf and C, you would use like an fgets or something. And some of the tools I would recommend if you want to learn is one, Google has a great tutorial for cross-site scripting that you can just follow along, completely legal, and will take you from some of the more basic attacks to some more complicated attacks. And then finally, make things. Make a home lab, make a web app, and make whatever your heart desires and you want to learn more about. Because by doing the thing, you can, well, you have to learn how to do the thing to actually do the thing. And would highly recommend that if you want to learn to just make things. So I know I went through a lot and we have a bit more time left over. So does anyone have any questions? Please don't be shy. Ask in the Zoom chat. I have it on screen. So do the thing and you shall have the power. Yeah, totally agreed. Learn how to do something and then you've learned how to do it by doing it. VPN. So the thing about VPNs, they just tunnel traffic from your computer to another remote resource. They're not this magical security catch-all. If you're worried about someone getting your IP for some reason, honestly, it's not a big concern because IPs mostly are public information, then like, if that's your concern, maybe. But if you're trying to prevent like someone from snooping on your passwords at a coffee shop, HTTPS in most cases is sufficient. And To add to that, actually, I don't have much to add to that. Unless you need to access like a remote resource that you can't in your current IP address, there's not much point to a VPN as a security tool unless you are working with HTTP logging connections. And then at that point, you're just pushing the unsecure part of the transaction to the remote resource, which if it's a shady VPN, might be doing some data mining in the process. See you around, Austin. Any more questions? Okay, if there's no other questions, then, well, if you have any in the future, please feel free to reach out to me. I swear I don't bite. So you can email me at jdavinson@hackucf.org. Reach out to me on Discord at sugar4187. I'm on the HackUCF Discord as well. Or follow me or whatever on Twitter at Jeffrey Codes or at Hey It's Sugar, whatever is your preference. So yeah, also this presentation is licensed under a copyright that is very lenient. So feel free to use the general images I created. This will also be on the canvas in the future. So I'll pass it off to Michael if he's still alive.
Yes, I am still alive. Thanks,
Yay,
Jeffrey, for giving a presentation today. So there's a few links in the bottom if you want to follow up with us later and stay in touch. If you're not already, as always, the Discord's always open to ask questions and talk with some of us here that you see in the meeting. Our website, new one coming soon, so keep in touch with that. And to follow more things that we post on all cyber things, please do follow our Twitter. So with that out of the way, we will all wish you a good weekend and see you next week. So until then, happy Friday.